All right, so when I did these differences where I subtracted, I made sure, and you don't have to change yours, but I made sure I took one and subtracted the previous one from it. That's why I have negative here. If you have positive, it's okay. The directions didn't say specifically what to do, so that's fine. And so, what did you guys notice about these distances? They're increasing. So each 2 second interval, the penny is falling more feet. All right, and then the graph is concave down. And so what do you know about the rates of change when a graph is concave down? Increasing or decreasing rates of change? Decreasing. So the rate at which the penny is falling, oops, is decreasing. And that seems like that's not true, but it technically is true when you're looking at negatives. So the rate of change everywhere on this graph is negative, basically because of gravity. All right, so these are the average rates of change, and it does verify what we said. These values are decreasing, so we're going to say yes. Right, and then I wanted this to look different. I didn't realize it until I was working it with my last class, but the speed is going to be the absolute value of the average rate of change. So speed never has a positive or negative sign. It doesn't have a direction. So if we're just talking about the speed, the absolute value of the average rate of change, is this penny speeding up or slowing down? Speeding up. And that's fairly obvious if you think about it, because gravity is affecting it. Okay, and then this is a typo. So I wanted you to go back to the values you found on problem 1 and find the differences between these. All right, and so I'm taking 1 and subtracting the previous one. Did you guys get all either 128 or negative 128 here? Okay. And so I hope that you notice that they're all the same. And that happens on every quadratic function. Those are called the second differences. And as long as these are equal intervals, so on your input values, they're going up by 2 each time, your second differences on a quadratic will be the same. Which differences do you think will be the same on a linear? Did it yesterday? The first differences are the same. So we're going to say these second differences are the same. All right. So let's go to the note sheet. All right, and this is all about change in quadratic functions. And quadratic functions have constant second differences over consecutive equal length input value intervals. We're going to write that so many times you're going to get tired of it. But because this is the first time this class is offered, I don't know how picky they're going to be when they grade your exam. But I do know if you word it this way, it is 100% right. So we need to make sure every time we say something about the second differences, it's over consecutive equal length input value intervals. All right, and the average rate of change over each interval grows or declines linearly. It's a hard word to say. And the rate of change of the average rates of change of a quadratic function is constant. So they are changing at a constant rate. All right, and then I just wanted to put in a reminder about concavity. It seems like you guys remembered it, which is great. But the graphs of quadratic functions are parabolas, and parabolas are either always concave up or always concave down. And concave up looks like a cup. And what we know about the rates of change when a graph is concave up is that the average rate of change is increasing. All right, and then concave down looks like a frown, and the average rate of change is decreasing. All right, so we just have this function. It's not related to any contextual information, which is fine. And so we are going to find the average rate of change on each of these 1-unit intervals. And I'm just going to do it by counting, if that's okay with you guys. So I'm just going to go from the point at -1 to the point at 0. And to do that, it's down 7, right 1. So that is the average rate of change of -7. All right, and then I'll just keep counting from point to point. Okay. And then B asked us to find the rate of change of the average rates of change. So it's a unit of 1, which makes it easier to do the rate of change because you just have to subtract. So how is it changing if it changes from a -7 to a -5? It's going up 2, right? And then same thing here. If from these two, it's also 2. All right, so what we just found was the rate of change of the average rates of change is 2. It's going to be constant if it's a quadratic function. All right. And then is this graph concave up or concave down? Up. All right, and then how does this support your answer in part B? So we got that the rate of change everywhere of the rates of change was 2, so that's a positive number. They're increasing by 2. So let's word it better than what I just said. So we're going to say the average rates of change are increasing by 2 on each, and I'm going to go ahead and write all the words so you're going to get tired of writing, on each equal length input value intervals. All right, now number 2 is a table, and we want to fix it. So it is the graph of a quadratic function. Now, I've taught a really long time, and I've never taught this. I kind of love it, actually. It makes you use some parts of your brain you might not be used to using whenever you're in math class. But so I know if this is a quadratic, all of these second differences need to be the same. So we're going to find as many second differences as we can. So when I do the first difference, we're going to make sure we take 1 and subtract the previous one from it. So I take 31, subtract 24, and I'm going to get 7. Oh, and I can only do this because these are equal intervals. All of these are going up by 4, so we can do this. All right, and then when I take 35 and subtract 31 from it, that's going to be 4. So that is going to make my second difference -3, because we're going to get from 7 to 4, you go down 3, or you can take 4 and subtract 7 from it. All right. So what I know as I go toward this direction, the second difference needs to be -3, which means this light blue 4 needs to go down by 3. So what would it make it? If I take 4 and go down by 3, make it 1. So inside my table, what does 35 need to go to? 36. That light blue means that it goes up by 1. All right, let's do some more. Last class, there were some people that was like, when filled in the whole table as soon as they saw that. It's pretty cool. All right, so I know this second difference needs to be a -3. So that means this light blue one needs to go down by 3, which means it needs to be a -2. And that means inside the table, the 36 needs to go down by 2, which is a 34. All right, you guys try this last point on the right on your own. See if you can figure out what that needs to be. Okay, so we needed a second difference, -3, which means light blue needs to go down by 3, which means inside the table needs to go down by 5. All right, and we're going to go the other way also. All right, so to go from this light blue to this light blue, this first one needs to go down by 3. So what would that be? 10. All right. And then inside the table, whatever is here to here, this first one needs to go up by 10 to get 24. So what is it inside there? 14. Oops. All right. Any questions on that? Okay. We're going to do another one in a second with a graph. So if you're still a little like confused, hang in there. We're gonna do some more. All right. So on the back, we have some tables. We have three tables, and we're going to determine based on the table if the function is linear, quadratic, or neither. And we're going to give a reason. Our reason needs to be very specific. All right, so to make that determination, we need to find the first and maybe the second differences. And so I'm just going to first double check that these are equal intervals. And so you are going up by 2 each time, so we can do this problem. So I'm going to take 1 and subtract the previous one. All right. So not linear. If this was linear, those would all be the same, and they're not. All right. Then I'll find the second differences. So take 1 and subtract the previous. And as soon as you realize they're not the same, we could actually just stop. And this one is going to be neither. And the reason is the first and second differences in output values. So that's what we were subtracting. The output values, which were the f of x, are not constant. Over consecutive equal length input value intervals. Yeah, it's a lot of writing. Okay, so that was neither. Let's look at G. So when I look at G, I look at the input values. We're going up by 3 each time. So we can do these differences and figure this problem out. So I'll take 13 and subtract 40, and that's negative 27. Take 4, subtract 13, it's negative 9. Just keep going. So this is not linear, but it's okay. It could be quadratic. So now I'm going to subtract these. And they are the same. They are constant. So if the second differences are constant, that means this is quadratic. All right, and we're going to give the reason. And the reason is the second differences in output values are a constant 18 over consecutive equal length input value intervals. Okay. And then on this last one, you might be able to just look at it and tell what it is. But if you actually find the differences, taking 1, subtracting the previous output, we do get a constant of negative 2. So what does it mean this graph is? Linear. All right, I'm going to write the reason. So the reason is the first differences in output or in output values are a constant, -2 over consecutive equal length input value intervals. All right, so we have one more, and this one is the graph, a parabolic function, which is a quadratic function. It's called m for some reason. And the question is find the y-coordinate of the vertex. So I'm going to make a table. You do not have to. You might have already figured this out. If this is something that is not quite clicking 100% in your brain, we're going to do a table. And I think you guys know that quadratic functions are all symmetric. So I know that if the point here is at -4, -5, this one should be at -2, -5. And I know if this point is -1, 1, then that one on the other side is going to be -3, 1. And what do you think that top one's going to be? Should be -4, 11. No, we shouldn't. I'm sorry. I spilled my coffee this morning. My brain is not working. Sorry, this is -5 and this is -6. All right, so let's put these bad boys in the table. All right, so I'm going to start doing some differences. So I'm going to start on the left, and I'm going to take 11. Sorry, I'm going to take 1 and subtract 11 from it, and then take -5 and subtract 1 from it. Okay. And then I'll also take -6 and subtract -10 from it. So if this is a parabola, that means all these second differences are going to be 4. So what does this little first difference need to be? If -6 is going up by 4, -2. So inside the table, that means -5 needs to go down by 2. And what's that going to be? Yeah. So the y-coordinate of the vertex is -7. Okay. And then the other question is to find m of -7. So I know -6. M of -6 is 11. I know my second difference is 4. So I know whatever is here goes up by 4 to get -10. So what is that number? 6 plus 4 is +10. I need to do something plus 4 is -10. It's -14. And so I would need to take something, subtract 14 from it, and get 11. So what would I take to subtract 14 from it and get 11? Nobody wants to answer. 25. Good. So that's m of -7 is 25. All right, you guys got to exercise your brains today for sure.